Yeah, okay, sir.
Okay, thank you so much. Uh, First of all, I would like to thank the ISA Kerala for this opportunity. It's a really commendable thing from ISA Kerala, because just about, I think, 12 13 days back, they thought that why can't they do this refresher course for PGs who are going to take the practical exam, because everything was uncertain. The practical exam dates were uncertain in Kerala, theory dates were uncertain in Kerala. So suddenly these ISA Kerala thought about just about 15 days back, and they were so good, they could get so many faculties in a short time. And now we are already starting the program. So really congratulations to everybody from ISA Kerala. So now I will also bring greetings from JSS Medical College Hospital, from where now presently I am working. Uh, you know, this lecture on anesthesia workstation and anesthesia machine is mainly for those people, for those postgraduates who are taking their practical exam. So what I have done is I have tried to think about whatever the questions that most of the examiners are going to ask about regarding the anesthesia machine and workstation, and I'm trying to answer all those questions, so that it can definitely help the students when they are taking the practical exam. So let me start the lecture, and it's very important for every one of you, the postgraduates who are taking your practical exam, to know more about the anesthesia machine and anesthesia workstation, because every day you are dealing with this equipment, and it is almost your part of your life throughout your life as anesthesiologist. And many questions will be asked for you in the exam, and they really test how much you know about the anesthesia machine and workstation. And I have come across many other students who are very eager to know about the anesthesia machine and workstation. So because they think that they don't know much about the machine and the workstation. Anyway, let me start my lecture. When anesthesia was introduced to the world by William Thomas Green Martin, that was on 16th October 1846. So he gave anesthesia for removal of a vascular tumor. The patient was Gilbert Abbott, and the surgeons were Warren and Bigelow. So you can see here, the Martin is holding just a simple ether flask. So he was not using any sophisticated equipment. So that's how the anesthesia was born. And for many years, the anesthesiologists were using only simple equipment, like their own handkerchief they were using, or they were using the Schimmel-Busch mask, and a very simple thing for open drop ether method. So then, one of the questions that one of the examiners was asking the students was, so why anesthesia machine was actually required? So in early part of the 20th century, what happened was these many of these gases were introduced in the compressed form in cylinders. So one of the questions that can be asked for you as a postgraduate is, what is a compressed gas? So a compressed gas is any gas stored in a cylinder with a pressure above 40 pounds per square inch at 70° Fahrenheit. A liquid also can be called as a compressed gas, especially, for example, nitrous oxide is there. So with a pressure of more than 40 psi at 100° Fahrenheit. So that means at room temperature and just above the room temperature, if these gases are having a pressure inside the cylinder of more than 40 psi, you call them as compressed gases. So when these gases, especially oxygen and nitrous oxide, were introduced in compressed form in cylinders, so there was requirement of a metal frame wherein these cylinders could be supported upon, and also the other volatile anesthetic or inhalation anesthetic agents would also be blended with these gases and could be administered to the patient. So that was the reason why there was a requirement of an anesthesia machine that was fulfilled by H.E.G. Boyle. So Henry Edmund Gaskin Boyle. Again, this is another question for you, that who introduced the first anesthesia machine and in which year? That was in 1917, Henry Edmund Gaskin Boyle. So the first manufacturers of the anesthesia machine were British Oxygen Company Limited. So these British Oxygen Company Limited, when they manufactured these anesthesia machines, So under the guidance of Boyle, they were so magnanimous, they gave this machine's name to Boyle himself. That's how they were on. These machines were called as Boyle anesthesia machines. So many of our senior surgeons, even today, even for the workstation, they call it as Boyle machine. So that was what that was done in 1917. Since that time, so anesthesia machine has come a long way. Now, presently, what we are actually using is, anesthesia workstation. Many places we hardly use the older anesthesia or a Boyle's machine. Now, majority of the OTs we are using anesthesia workstation. So for the practical exam, both the older anesthesia machine and the anesthesia workstation will be kept side by side. So many of the students will be asked what is the difference between the anesthesia machine and the workstation. So one thing is very important to answer is the anesthesia machine is a purely a pneumatic one. It doesn't have electrical and electronic components, whereas the anesthesia workstation has got the pneumatic system also and also has electrical and electronic systems as well. And one more difference is that the anesthesia workstation has an integrated ventilator and integrated monitors, which the anesthesia machine doesn't have. And the most important of all these is, the safety features. So over the many years, many of the safety features have been added, and presently what we have is a foolproof anesthesia workstation with many, many safety features. Why these safety features were required is mainly to prevent hypoxic mixture being delivered to the patients. So that's how the most important difference between a machine and a workstation is the machine hardly has any safety features, whereas workstation is full of safety features. In the world, the two giants manufacture the anesthesia machines. So mainly, Datex Somada, that is GE now presently, and the Draeger. So there are few of the differences between the Draeger machine and the GE machines, in their structure and also in their functioning. So many times in the exam, you may be having a Draeger machine for you to answer, or you may have a Datex Somada machine for you to answer. So it is always better to know some of the differences between GE machine and Draeger machine. So in my lecture, I'm also talking about few of the differences of these two workstations. So most of the questions for you that are asked in the exam are regarding the pneumatic component of the anesthesia workstation or the anesthesia machine. So you will have to know more about the pneumatic component. So in the older machines, everything was very transparent. If you just open the lid out of the anesthesia machine, so you could see everything. The whole skeleton was seen. Nowadays, the workstation, everything is covered. So you may not know what is there inside as far as the pneumatic system is concerned. So let me talk to you about this pneumatic system, because many of the questions that are asked. So one thing is how this pneumatic system of the anesthesia machine is classified. It is basically classified based on the amount of pressures inside the different parts of the machine. So it is classified as high pressure system, so the intermediate pressure system, and the low pressure system. So the high pressure system is, it is mainly from consists of the cylinders. From the cylinders up to the pressure regulator is the high pressure system. From the pressure regulator downstream up to the flow control valves is the intermediate pressure system, and from the flow control valves up to the common gas outlet is the low pressure system. So what is the pressure inside these high pressure, intermediate pressure, and low pressure system? So high pressure system, you all know that it is mainly the cylinder pressures. So what we have usually, we have the nitrous oxide and oxygen. So oxygen pressure is roughly about 2000 pounds per square inch gauge pressure, and nitrous oxide is the vapor pressure of nitrous oxide at 20 degrees centigrade, is 750 psig. So this is the pressure in the high pressure system. So what is the pressure in the intermediate pressure system? You see, in the older machines, even the pipeline was attached to the yoke of the anesthesia machine itself. Now, in the modern workstation, the pipeline is mainly attached in the intermediate system. Directly, it has got a separate inlets for pipeline. There it is attached. So the pipelines are in the modern workstations is in the intermediate pressure system. So the pipeline pressure is 50 to 60 psig, whereas the cylinder pressures or reduced to 45 psig by the pressure regulators. Now, this is one again common question that is asked is suppose I'm using a workstation and have opened the cylinder for initially checking. I have forgotten to close the cylinder, and I have also connected the workstation to the the pipeline system. So now when I start using this the workstation, which gases are preferentially used by the workstation? So this is one common question that is asked. Now that is the reason. See, now the pipeline pressure is entering into the system, into the intermediate system at 50 to 60 psig, whereas the cylinder pressure is entering into the intermediate system at 45 psig. This is deliberately done so that whenever you keep the cylinders open and also pipeline connected, only the pipeline oxygen is preferentially used. So this is very important. This you should always know. Whereas in the world, this is one of the safety features that is adopted. In the older machine, because the pipeline was connected to the yoke and also cylinders were also connected to the yoke. So suppose if you open both cylinders as well as the pipeline is connected, and then the cylinder pressure being high, probably the cylinders would be preferentially used. Actually, the cylinders are always kept as the backup source of oxygen. So if cylinders are exhausted, so if pipeline pressure is also exhausted, then if you want to fall back on the cylinders, you will not have any source of oxygen. So that's how this is one of the safety features that is included by making the pipeline to be connected into the intermediate system. So even though one thing I want to caution you that even though this particular safety feature has been adopted, never keep the cylinders open. So once you check the cylinders in the morning, so close the cylinders, because there can be a lot of fluctuations in the pipeline pressure. Because it's fluctuations of the pipeline pressure, the cylinders also may get used up. So when you want to open up the cylinder for backup, there may not be any oxygen for you to use. So the low pressure system, so you have just above at the common gas outlet, you have just above the atmosphere, that is about 5 to 8 pounds per square inch gauge pressure will be there. So let us discuss about the individual systems, high pressure, intermediate and low pressure system. So the high pressure system, mainly, it consists of the cylinders, the hanger yoke, then the pressure gauge and the pressure regulator. So a lot of questions will be asked for you regarding the cylinder. So let me talk to you more about the cylinders in the high pressure system. Now, many times you will be asked what are the parts of a cylinder. The cylinder mainly consists of a body, the shoulder, the neck, and the cylinder valve. So one thing you should again realize that the cylinder valve is a separate entity. It is not a part of the cylinder. It is connected to the cylinder. So that means the cylinder has got two parts. One is the main body of the cylinder, and the second thing is the cylinder valve. So one of the safety features in the cylinder make itself is it has got a seamless body. So this is very important to know what is meaning of seamless. Seamless means no joints. So if the cylinder has joint, that would be the weakest point there, and highly compressed gases with high pressure will be inside. And if there is a joint, it can give way, and there can be the problem of leaking of the cylinder can occur. So this is one of the safety features of the cylinder, make that it has got a seamless body. Now coming to what is the material with which the cylinders are made of. See, cylinders originally when cylinders were introduced, they were made of hand forged steel. So one of the problems with hand forged steel was its tensile strength was very less. So because its tensile strength was very less, so the walls of the cylinder had to be made very thick. So because the walls of the cylinder had to be made very thick, so it used to weigh heavy, and also the internal volume of the cylinder was much less. Now presently what we have is the cylinders made of molybdenum steel. So because of this molybdenum steel, the tensile strength of the cylinders is quite good, and because of good tensile strength, the thickness of the walls of the cylinder could be reduced. So they weigh 20% less than the older cylinders, and they also have an increased capacity of 20% of gas mode. So we also have aluminum cylinders are also available. That is mainly for the MRI suits. Now, many times you'll be asked about the markings on the cylinder. So what are all the markings on the cylinder? So it is always better to know about. Many times, modern whatever the cylinders what we are using, so markings would have gone already because of repeated use and also repeated painting on the cylinder. But for exam going postgraduate, you should always know about what are the markings. So on one side, you can have the DOT specifications, that is Department of Transport specifications are there. You can see here a 3AA is written here. So 3AA means it is made of steel. 3AA means steel. And another 2015 is written. 2015 is the service pressure. So many times you may be asked, what is this service pressure? The service pressure is the pressure with which oxygen is filled inside the cylinders for use by the user. That means usually it is filled to the maximum of 2000 psig plus 15 is the atmospheric pressure. So 2015 psia will be the pressure with which it is filled. So that is also written marked on the cylinder. So you should always know what is the service pressure. It is roughly 2015 pounds per square inch absolute. So the other side, you can see here, it is written EE 17.5. So this E is the elastic expansion of the cylinder. So these cylinders are tested once in 5 to 10 years by hydraulic testing most of the time, and they are tested at 1.6 times their service pressure. Service pressure is roughly 2000 psig. So 1.6 times can be about 360 psi. So when they are pressurized to this high pressure, they should not expand. So how much there can be a minimal expansion. So this is just about 17.5 cc minimal expansion. That means this cylinder is fine and has got a good tensile strength. Now the next thing is, it is also written as the actual material with which these cylinders are made, that is chrome molybdenum steel, that is used for the manufacturing of this cylinder. So one thing I just want to tell you about, many of the students usually do not answer when I ask them about this. So invariably between the cylinder valve and then the body of the cylinder at the shoulder level, there will be a plastic disc or a metal disc. So when I ask what is this disc for, so usually majority of the students do not answer. This is mainly, on this disc, the marking of the date on which when the cylinder last has been tested would have been marked there or etched on a metal ring there, so or a disc. So this you should always know about. So sometimes even three instead of 3AA, there can be 3AL or 3ALM. That shows that the cylinder the cylinders are made of aluminum. Now the other markings, especially the tear weight. So this is another very important thing about to know. Many times you will be asked what is the tear weight. Tear weight is nothing but weight of an empty cylinder. So why should we know about the weight of the empty cylinder? This I am going to talk to you later when I will talk to you about the nitrous oxide. So because if you want to know how much of nitrous oxide gas is available, you have to know how much of the weight of the liquid nitrous oxide that is there inside the cylinder. So in order to know how much liquid nitrous oxide available, so you have to know the tear weight. So the total weight minus the tear weight, you know that the amount of liquid nitrous oxide availability you can know. That's why the tear weight is very, very important for you to know about. And these cylinders are usually, their size is based on the alphabets. They're, from B to M alphabets are based on the size of these cylinders. So on the quantity of inside the cylinder. So D and G cylinder, you can see these D and G cylinders are the ones that we usually used to mount them directly onto the yoke assembly of the anesthesia workstation. So why D and G only is because they do have pin index safety system that I am going to explain to you later. And another thing I was talking to you about the tear weight. So each type cylinder most commonly used, less commonly used is D-type cylinder. Since the most commonly used D-type cylinder, the tare weight is about 5.4 kgs. So you should also know about this particular thing. Coming to another safety features of the cylinders, that is the color coding of the cylinders, which was introduced in 1949. You know, the oxygen this particular color coding was both the cylinder body and the shoulders were color coded. Like oxygen was black with white shoulders, black body with white shoulders, nitrous oxide French blue, both shoulders as well as the body, carbon dioxide gray, and helium brown, and cyclopropane orange, and entonox blue body with blue and white stripes. So in 2010, a new international color coding has been introduced. Of course, this has not been introduced in India, but you may be asked in the exam, so it is better to know. And this new international color coding is mainly for medical oxygen cylinders, medical cylinders. So once you know that the body of all the medical cylinders are colored white. If a cylinder is body of the cylinder is white, you know that it is a medical grade gas containing cylinder. So only you can recognize the particular gas by its shoulder. So you can see oxygen, so body and the shoulder are both white, whereas nitrous oxide, the body is white and the shoulder is blue. Like that, entonox, the shoulder is both blue and white, and helium is brown. Like that, all these are the new international color coding. And one more thing here, N is always a capital N is written on the shoulder of these cylinders. N signifies that it is a new international color coding that has been used for these cylinders. Now coming to the cylinder valves. Cylinder valves are not made of molybdenum steel. You should always know that they are separate parts. They are made of brass and chromium plated. So these cylinder valves, the one side that you have to connect it to the machine side, you have the pin index holes and the port. The opposite side of that, you have the conical depression, and just below the conical depression, of course, not in Indian cylinders, you can also have a pressure relief device. Now, these cylinder valves, sometimes they'll ask you what are these type of cylinder valves. They are called as the direct cylinder valves, or otherwise also called as pack valves, because a Teflon packing is there, and the spindle is there. Once you rotate the spindle anti-clockwise about 3 or 4 times, this pack will open up the port so that the gas from inside directly can enter into the anesthesia machine. So that's why these are called as pack type, and also they are also called as the direct acting valves. So here, one thing I just want to tell you about is, that there is a gland nut also will be there just below the or packing nut or the gland nut just below the spindle. So why it's important to know is because in one of the examination centers where I had gone, I'd asked the students, every student I asked actually to open the cylinder. So every student tried to open this packing nut or the gland nut. It is very dangerous to open the gland nut, because if you open the gland nut, the leak will start off from inside. So many times if there is slight leak is there, you have to tighten this gland nut. So when I asked those, the internal examiners, why none of the student do know about how to open the cylinder, because they said that all the time, 24 hours, we have the pipeline system. But that is not the answer. You see, every student should know how to open the cylinder, and every morning before he starts, you should always open the cylinder and see whether backup gases are available for us to go ahead whenever there is any exhaustion of the pipeline gases are there. So it's always you have to open the spindle, or otherwise called as a stem. Now coming to the pin index safety system, it is one of the popular questions by majority of the examiners. So it is better you know about it. And the one thing sometimes may be asked is, so who introduced the pin index safety system and which year? So Philip Woodbridge introduced the pin index safety system in the year 1952. So here, from the port, this is the port of the cylinder. From exactly center of the port, at a radius of curvature of 9/16 of an inch. So usually this particular measurement is usually asked for you in the exam. So 9/16 of an inch of a radius of curvature. So holes are made from right to left. So you can see the holes here. Now these holes are numbered from right to left: 1, 2, 3, 4, and 5 and 6. So 1 and 2 will overlap on each other. Actually, 2 and 3 will overlap. So 3 and 4 usually do not overlap on each other. 4 and 5 overlap, and 5 and 6 overlap on each other. So correspondingly, the on the yoke assembly there will be pins. So the pins and the yoke, the holes on the cylinder valves should align with each other. Then only you can connect a particular cylinder onto that particular side of the yoke. So this is a fantastic safety system that was introduced by Philip Woodbridge in 1952. So many times they'll ask you again, another measurement is the diameter of the holes. The hole's diameter is about 4.75 millimeter. The diameter of the pins is 4 millimeter. The length of the pins is 6 millimeters, and depth of the holes is also 6 millimeters. So this also, it is very important for you to know about. And again, the pin index numbers are very commonly asked. Most of the time we have oxygen, nitrous oxide, and air. They are the cylinders which you can usually mount them onto the machine, onto the yoke assembly of the machine. So as long as you know about these three, it is more than sufficient. See, oxygen is 2.5, nitrous oxide is 3.5, and air is 1.5. So when you talk about oxygen, nitrous oxide, and air, so fifth position is common among them. So only the first position is for air, second position is for oxygen, and third position is for nitrous oxide. So 1.5, 2.5, 3.5. So if you just remember this, it is more than sufficient. Sometimes if you want to know more, then you can also know that carbon dioxide is 1.6 and NOx is 7. NOx is a single one, and in between 3 and 4, this NOx 7 hole will be there. Now, one more safety feature. So this also you should know for the exam purpose. So suppose when during transportation or during the storing, suppose if these cylinders are kept in sun, so what will happen? The gas inside, because of the increase in temperature, try to expand. Now the volume is trying to expand because volume and temperatures are directly proportional to each other based on the Charles law. But here the tensile strength is so good, so the cylinder will not allow the volume of the gas to increase. So since the volume does not increase, the pressure and temperature are also directly proportional to each other based on Gay-Lussac's law. The pressure starts increasing. So once the pressure reaches a critical pressure, there can be the cylinders may break and even can produce collateral damage. Now, what is the safety feature that is adopted to prevent this particular catastrophe to occur? So I was telling you, just below the conical depression, you can have the pressure relief device. So this pressure relief device can be of a ruptured disc type, or a fusible plug type, or a combination of these two, or it can be just a pressure relief valve. So we'll just talk about this. The fusible plug is, many times it can be asked for you. The fusible plug is usually contains a metal called as, or an alloy called as Wood's metal or Wood's alloy. So very common question is, what are the components of the Wood's alloy? The components of Wood's alloy are cadmium, bismuth, lead, and tin. So what is the speciality about Wood's alloy is that it melts at 150 to 170 degree Fahrenheit, a very low temperature it melts. So what happens is, suppose when these cylinders are kept in sun, so the gas will, the pressure and volume try to increase and temperature increases. Once the temperature reaches this 150 to 170 degrees Fahrenheit, so this fusible plug will start melting, and once it starts melting, so the gases are vented out, and dangerous catastrophe can be prevented. So one thing about the fusible plug is it's a non-closable type of safety relief valve. That means once it opens up, so you'll have to send it to the company to again replace the fusible plug. So other one is the ruptured disc. So the ruptured disc mainly consists of copper as a disc there. So this copper the thickness of the copper is made in such a way that it breaks open at a particular pressure that is developed by the gas inside, because when it is get heated up. So once it breaks open, so the gases are vented out. Again, this is a non-closable type of the pressure relief device. The third type is the pressure relief device. That is, it's like in our pressure cookers in our kitchen. So what this particular type of relief device is, now it has got the valve seat is there and it is connected to a spring. So usually the valve seat closes the discharge channel. So suppose once the cylinders are heated up and the pressure increases, so this particular seat pushes the spring and then it opens up the discharge channel, and the gases can be vented out. So once the pressure inside the cylinder comes back to the normal pressure, so the disc or the particular valve seat comes back to its original position, closes the discharge channel. So this type of pressure relief device is called as a closable pressure relief device. But why we usually this is not popular at all? Because it may malfunction. So you must have seen many places the cooker getting burst and all those problems are there with such relief devices. Same thing can occur with this particular relief device also. So that is the reason it is not commonly used, though the advantage is that you need not have to send the cylinder back. So most commonly used is either ruptured disc or fusible plug or a combination of those. But in the exam, if you are asked, show the safety relief device, pressure relief device, you try to look for it just below the conical depression. It is not there in Indian cylinders. Then you can ask, so what precaution or what method of safety is adopted in our Indian cylinders? Now, if you see here, this cylinder valve has got threads are there. So this particular part of the cylinder valve, it is screwed into the shoulder of the cylinder. So when it is being screwed inside, between the threads of the cylinder valve and inner lining of the shoulder of the cylinder, the Wood's metal is incorporated. This is what you have to tell in the exam, that we don't have a safety relief device, but Wood's metal has been incorporated in between the cylinder valve and then the body of the cylinder. So whenever the temperature increases, so this will melt and the gases are vented out. So another common question that is asked is cracking the cylinder. So many of the students would have not known about what is this meaning of cracking the cylinder. The cracking the cylinder is, when the cylinder is brought and then it has to be connected onto the machine, you have to see that there are absolutely no dust particles inside the port. Because if there are any dust particles inside the port and we connect the cylinder onto the workstation and we open up, these dust particles can enter inside, can block the fine needle valves and can obstruct the flow of gases, one thing, or they may catch fire and they can produce quite a bit of explosion. So that is the reason why it's very important to open the cylinder before connecting the cylinder onto the machine. And whenever you want to open this is called as the cracking of the cylinder. So again, you'll be asked, how do you open the cylinder? So many of the examiners are fond of asking you to demonstrate how do you open the cylinder. Now, what the examiner wants to see is that whenever you are opening, your head is not just above the cylinder valve. So you always incline the cylinder, body of the cylinder forwards and then open a little bit so that the gases are just a small amount of gas will come out and throw out any dust particles. So that is what you have to bend it forwards and then open it. Never keep your head above the cylinder when you are opening. So this is what the examiner wants to see, how do you crack the cylinder. So again, once you connect the cylinder onto the the machine and also to the workstation, so you may be asked, how do you open the cylinder? So the answer should be you are going to open very slowly. So and minimum 3 to 4 turns have to be rotated anti-clockwise to completely open the cylinder. So why should you open it very slowly? What happens if you open it rapidly? That is another question that will be asked for you in the exam. So what happens is when you open it rapidly, because suddenly so much of high pressure gas will try to enter into the workstation. So it goes through the yoke assembly and tries to enter the pressure regulator. And before the pressure regulator could reduce the pressure of these gases, so there can be large amount of gas trying to accumulate in a small area between the yoke assembly and the pressure regulator. So what happens is now the gas gets really compressed. So whenever the gas is suddenly compressed, it gains a lot of heat energy, and which is called as the adiabatic process, wherein this heat energy, because it is gained so suddenly, it cannot be dissipated to the atmosphere. And this process is called as the adiabatic process. Again, this particular question will be asked, what do you mean by an adiabatic process, especially when you're opening the cylinder. So why should you know? Because high heat energy is released here, and suppose if I was telling you that if there is a dust particle, so that will catch fire and that can produce an explosion. So that is why whenever you are asked how do you open the cylinder, you should say that you will be opening the cylinder very slowly and not very rapidly. And so this also is commonly asked, test for tensile strength. I already told you that once in 5 to 10 years, these one of the cylinders of that particular batch is tested, and the marking is done for all the cylinder of that batch that it has been tested, and the tensile strength is good. So what are the different tests that are done? So usual majority of the time, the most commonly done test is the hydraulic testing. The other tests are flattening test, impact test, and bend test. So in order to do this flattening test, impact test, and bend test, you have to break open the cylinder. So for hydraulic testing, you need not have to break open the cylinder. So that is why the hydraulic testing is the most commonly done. So what it is done, how it is done is, these cylinders, the empty cylinder is placed inside a water jacket. Once the empty cylinder is placed inside a water jacket, the water column rises. So there is a gauge here, the glass tube is there, a gauge is there. Inside that, the water column will increase. Now how testing is done is, the water is made to enter into the empty cylinder, and by continuously increasing the amount of water, the inside the cylinder, it is pressurized to 1.6 times the service pressure. That's what I was telling you. Service pressure is 2000 psig, so it is increased to 1.6 times the service pressure. At this service pressure, if this cylinder expands, the level of this gauge will go up. So that is what is looked for, and it should not go up much. It should be a minimal, like I was telling you, just about very minimal, about 15 cc increase in the elastance was there. So that is okay. So that is what is the hydraulic testing that is most commonly done. Now again, filling of the pressures, cylinders. Now filling of the cylinders for oxygen, it is very easy, because oxygen at room temperature, it exists as a gas because its critical temperature is minus 118 degrees centigrade. So it always remains as a gas at room temperature. So it is filled based on the pressure. That is the service pressure. I told you up to 2000 psig, it is filled and then sent for the use. Whereas nitrous oxide, it's a liquid gas, and the gauge pressure always will be showing the vapor pressure at 20 degrees centigrade, that is 745 psig. So this cannot be filled based on the gauge pressure or the pressure. So usually it is filled by using what is called as the filling density. So this is another question you will be asked about, how liquid gases, especially the nitrous oxide, is filled. So the filling density is nothing but weight of nitrous oxide divided by weight of water. So the inside the cylinder capacity is about 5 liters, because density of water is 1. So 5 liter of water will weigh 5 kgs. So the denominator is 5 kgs. The numerator is weight of nitrous oxide. In tropical countries, the filling density or filling ratio, sometimes it is also called as, is 0.68. Suppose I want to know a fully filled nitrous oxide E-type cylinder, how much it weighs. So you see 5 multiplied by 0.68, it is 3.4 kgs. So total weight of the cylinder with the nitrous oxide, because you have to add the tare weight, so it should be around 8.8 kgs. So when the cylinder is supplied to you, the E-type cylinder, if you weigh it, and if it is 8.8 kgs, you can say that it is completely filled. Now, another thing is, suppose if they use this 3.4 kgs of nitrous oxide, do you think that the whole of the cylinder will be filled? No, it should not. They should not fill the whole of the cylinder. A part of the cylinder has to be kept open for vaporization of nitrous oxide. That means with this 3.4 kg of nitrous oxide, when it is being filled, so 90 to 95% of the cylinder will get filled. So another 5 to 10% of the top will be kept open for the gas to vaporize. So this is another question can be asked, and so you should know what to answer. So in a nutshell, safety features of cylinders, molybdenum steel is the make, high tensile strength, color coding, seamless body, safety relief valves, and index safety system. So these are the safety features of cylinders. Now coming to the hanger yoke assembly. So this is the hanger yoke assembly, which is there on the workstation or on the anesthesia machine. So usually it consists of a body and the retention screw or retaining screw. It is to retain the cylinder onto the workstation, and you have pins for pin index safety system. You have a nipple here which goes into the port of the cylinder, and around the nipple you have the Bodak seal, which maintains a leak-proof connection between the cylinder and the machine. Now, what are the functions of the yoke assembly? So this is another question you may be asked. It supports and orients the cylinder to the machine. It maintains a leak-proof connection between the cylinder and the machine. I told you that is because of the Bodak seal. And third is it maintains a unidirectional flow of gases towards the machine, so that always when you open the cylinder, the gases will be flowing only towards the machine and not away from the machine. So in the older machines, you can see these yoke assembly used to be on the sides of the machine, whereas the modern workstations, they have been shifted to the back of the machine, just below the pipeline inlets. So these are the yoke assemblies that are there in the back. So I was telling you about the Bodak seal, and usually you will be asked about what material the Bodak seal is made of. So Bodak seal is made of neoprene rubber, and this neoprene rubber is a very thick rubber, and it will not give way very easily. And it also has got a metal aluminum ring. So because of neoprene and the metal ring, so this wear and tear is minimal, and these Bodak seal will have a long life. So one more question that can be asked is, can I use two Bodak seals? So you should always say you should never use two Bodak seals. Even if there is a leak, you will have to know why there is a leak. So use only one Bodak seal, because if you use more than one Bodak seal, you can nullify actually the pin index safety system. So that is what the answer should be. So I was telling you that the unidirectional flow of the gases, how these unidirectional flow of gases in the yoke assembly is maintained, it is because of the check valves. You can see in this particular figure. So when the cylinder has been opened, the gases are moving. So the gases are moving towards the machine. Suppose if the gases are trying to move back through the other yoke, so the check valve will not allow it to come out. Suppose if I am not using any cylinder, or I'm not plugged this yoke, so there won't be any leak. But one thing you should always realize, many times these check valves may not work properly. So that is the reason you should never allow a yoke to be kept open. Because if you keep the yoke open, so the chances that if the check valve is not functioning properly, the gases may leak out, and you may have an empty cylinder. Or you should not connect an empty cylinder also, because there can be transfilling of the empty cylinder from a full cylinder. So in order to prevent that, you have to plug the yoke assembly all the time whenever you are not using the yoke assembly, and that is called as the yoke plug. So you can see here, there is the yoke plug. So this yoke plug is a small metal piece with a hole on the machine side where it accommodates the nipple. The other side, it accommodates the retaining or retention screw. So this it will be hanging by the side of the yoke. Many times we will be asking you, what is this yoke plug, or what is this particular part of the machine? and many of the students do not answer. You should know that it is a yoke plug, mainly to plug the yoke when it is not in use. You can see here, this is how the yokes which are not being used are being plugged by the yoke plug. So one more part you should always know about, because I told you, because the older machines also will be kept for the exam, and in the older machines the pipeline used to be connected directly onto the yoke, and how it is connected directly onto the yoke is by using what is called as yoke block. So you should always remember to differentiate between a yoke plug and a yoke block. So this is the yoke block is mainly to connect the pipeline onto the yoke assembly. So see, this is the yoke blocks. They are almost look like cylinder valves. And one question is asked for you is, there are pin index holes. So many times these yoke blocks will have pin index holes on either side. So they may ask you why pin index holes are made on either side, because the cylinder you cannot connect it to the yoke upside down, but definitely you can invert these yoke blocks and then connect onto the machine. So then if you invert them and connect, if there are no holes underneath the port, then definitely you can nullify the effect of pin index safety system. So that's how the pin index holes have been made on both sides of the port, so that even if you invert and try to connect, you cannot nullify the effect of pin index safety system. So coming to the inlets of the pipeline connections. So usually these inlets of the pipeline connections are on the back of the anesthesia workstation. So another very important thing about these, though the inlets are of these are actually the part of intermediate pressure system, I would like to discuss here only. So these inlets also have got a safety systems when they are being connected with the pipeline connectors. That system is called as diameter index safety system. So this, otherwise this also short form. So many times you may be asked about this diameter index safety system. So this, you have a nut and then a stem on the pipeline connector side, and you have body on the workstation side. So the diameters of the body and the diameters of the nut and stem have to approximate each other. Then only you connect a particular pipeline onto that particular body of the inlet on the workstation. So otherwise you'll not be able to connect, because they don't align with each other, and this is called as the diameter index safety system. So here one thing you should realize, the nuts and then the stem both are diameter index. Whereas you have one more type of connection safety system, that is called as a NIST connectors. This NIST connectors is nothing but non-interchangeable screw threads. So here the nuts are not diameter index. The nuts of all the other gases are also of the same diameter. Only the stem or the probe is diameter indexed. So majority of the British-made workstations, you will have this disconnect and the NIST connector, that is non-interchangeable screw threads. Whereas American manufactured workstations, you have diameter index safety systems. So inside the inlet of these, the pipeline at the workstation end, so you also have a check valve, so that even if no piping has been connected, so the gases will not come out. So this is another safety feature that is adopted in the inlet of the piping pipelines inside the workstation. So at the wall outlet, again, you have a diameter indexed connections are there. Though they are diameter indexed, they are not called as disconnectors. They are called as quick couplers or Schrader valves. So, why they are called as quick couplers? You can couple them onto the wall outlets and decouple them very rapidly, quickly. That's why they are called as quick couplers, or otherwise called as Schrader valves. They are also, these valves, wall outlets are also color coded. Even the pipelines are color coded. These are all the safety features, so that you should not connect a wrong pipeline onto a particular type of the wall outlet. Now coming to the pressure gauges. So these pressure gauges were just above the yoke assembly in the older machines, but in the newer workstations, these pressure gauges have been shifted to the front because the yoke assemblies have been shifted to the back. So the pressure gauges have been shifted to the front. And one more thing you can observe in the modern machines, which was not there in the older machines, is again a very important safety feature, is that you have pressure gauges for the pipelines, pipeline gases also. You can see these three are the pipeline pressure gauges, and lower down you can see the cylinder marking here. It is for the cylinder, so that you are able to know what is the pressure inside the pipeline system also. So suppose if the indicator starts falling in the of the pipeline pressure gauges, then you know that that particular gas is getting exhausted. So you know when to open up the reserve or backup cylinder. So this is a very important safety feature that is adopted in the modern workstations. These Borden's pressure gauge, again questions will be asked regarding this. So usually the pressure gauge that is called as a Borden's pressure gauge, it mainly consists of a copper tube. It is bent in a C-shaped bend, and the tip of the copper tube is it is closed, and it is connected to through a clockwork mechanism or a gauge. So indicator is there. So indicator will be there on the gauge of the pressure gauge. So what will happen is, suppose when you open the gases, so the gases with high pressure will move inside and it will straighten this C-shaped tube. Once the C-shaped tube is straightened, so it moves the indicator on the pressure gauge, and that will give you what is the pressure of the gas inside. So some of the safety features they can ask you about is that the pressure gauge in the older machines used to have a very thick a glass in front, which usually is break proof, it won't break. And the back of the pressure gauge used to be having a thin metal sheet. So suppose if this tube breaks, the gases will flow out only from the back of the pressure gauge and not from the front. That is one of the safety features adopted. The other safety feature adopted was also color coding of these pressure gauges. So if you can see this here, you can see the color coding of the pressure gauges. Oxygen is white and nitrous oxide is blue, and the air is black and white. So now, so some of the older machines also in some of the places I have seen be kept. So this particular machine, if you see, initially they had only the pressure gauges for oxygen and they did not have pressure gauges for nitrous oxide. So this particular question may be asked for you, why there are no pressure gauges initially for nitrous oxide. So this is because oxygen is a gas. So because its critical temperature, I told you it is minus 118 degrees centigrade. So because the room temperature is much above the critical temperature, oxygen cannot be compressed into its liquid state. So it remains as a gas. So because it remains as a gas, the pressure gauge directly shows the contents of the cylinder with oxygen. So that is based on the universal gas law, PV is equal to nRT. So this universal gas law is in a combination of Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's hypothesis. Here, if you can see, the PV is equal to nRT. So the pressure multiplied by volume is equal to the number inside number of molecules. R is the universal constant, T is the temperature. Here, volume inside the cylinder is constant. So then R is a constant, and P at a particular time is also, temperature is also constant. Now P becomes directly proportional to N. So that is the reason that whatever the pressure gauge shows, the pressure gauge will be showing the contents of the oxygen cylinder. That's why when it is full, it can show roughly about 2000 to 1900 psig. So then if it is 3/4 full, it can be about 950, and half full 475. And when the indicator shows 0, that means there is no oxygen inside. So this is not the same case with nitrous oxide. I also already told you the critical temperature of nitrous oxide is plus 36.5. It is much higher than the room temperature. So nitrous oxide always remains as a liquid at the room temperature. Because it remains as a liquid, so whatever the pressure gauge is showing is the vapor pressure at 20 degrees centigrade. So till the last drop of nitrous oxide is there, the vapor pressure remains at the same 745 to 750 pounds per square inch. Only when all the nitrous oxide liquid is evaporated, then the indicator starts falling. So once you know that the indicator has started falling, then you know that there is no liquid nitrous oxide and it may get exhausted in a 1 or 2 hours time. So that is why in the newer machines, the pressure gauges have also been introduced for the nitrous oxide also, so that you know that when nitrous oxide is getting exhausted. So coming to the contents, this is another question that is asked. How do you know that based on the pressure, how do you know that how much oxygen is there? So this is the Boyle's law you'll have to use. And most of the students usually answer this particular thing because Boyle's law says that pressure and volume are inversely proportional to each other at constant temperature. So you know that you can write it down as P1 V1 is equal to P2 V2. So P1 is the pressure or inside the cylinder, and V1 is the the E-type cylinder is usually about 5 liters. So we are going to use it at 15 psi. That is A, that is atmospheric pressure. So V2 is the volume you want to know. So you can calculate, and usually an E-type cylinder will have about 660 liters when it is completely full. So whatever the pressure, you can easily calculate, and based on that, you know how long the cylinder can be used. Whereas nitrous oxide, the pressure gauge is not showing you the contents. So whenever the nitrous oxide cylinder is there, so you want to know how much of nitrous oxide is available for you to use inside. So that you have to use the Avogadro's hypothesis, which states that 1 gram molecular weight of any gas or vapor occupies 22.4 liters at standard temperature and pressure. Here, standard temperature is always 273 kelvins or 0 degrees centigrade. Standard pressure is always 760 millimeters of mercury. So now the molecular weight of nitrous oxide, N2O, nitrogen is 14, 14 into 2 is 28, oxygen is 16. So 44 is the molecular weight of oxygen, nitrous oxide. So when this molecular weight is expressed in grams, it is called as the gram molecular weight. So 44 grams of nitrous oxide with this Avogadro's hypothesis should occupy or give 22.4 liters at 0 degrees centigrade or 273 kelvins. So if we just convert this at room temperature of 293 kelvins, so you know that the same 44 grams will yield about 24 liters. So this 44 grams will yield 24 liters. 1 gram will be yielding about 0.55 liters. So this, you know that 1 gram at 20 degrees of nitrous oxide will give you about 0.55 liters. So now once you know what is the amount of nitrous oxide that is present, because if you weigh the total, if you weigh the nitrous oxide cylinder minus its tare weight, you know that it consists of the weight of the nitrous oxide inside. So usually it is about 3.3 kgs or 3,300 grams. So now you know that at 20 degrees centigrade, an E-type fully filled nitrous oxide cylinder will give you about 1,815 liters. So that's how easily you can make out, and if you're using for 3 liters, how long you can use it. So easily you can make out that how much nitrous oxide you can use it. Now coming to the pressure gauges. So in many of the modern workstations, you don't have these kind of pressure gauges. You have electronic pressure sensors are there, and you can directly see whatever the pressure that is there on the monitor of the gases, including the cylinders. Now coming to the pressure regulator. So the pressure regulator is another very important thing for you to know. And usually you will be asked what is the basic principle with which the pressure regulator functions. That is, the basic principle is force is equal to pressure into area. That means when you keep the force constant, if you increase the area, the pressure automatically drops. So you can see in this figure, when high pressure gases are entering into a chamber having a wide diaphragm of a wide area, automatically the outlet pressure will come down. So this is the basic principle on which the pressure regulator works, and in the exam you may have to answer this. So why a pressure regulator has to be there? So you'll be asked about functions of the pressure, why the pressure from the cylinder has to be reduced before it is used it is given into the or administered into the machine. So many of you will be talking about prevention of barotrauma. So that is the last function of the pressure regulator. The main function of the pressure regulator is to provide a constant pressured gases to the flow meters so that the flow does not change. Suppose you have a 2000 psig of oxygen. If you don't have a pressure regulator, what will happen is after some time the pressure inside the cylinder starts coming down. So the whatever the flow you are keeping in the flow meter also will start coming down. So every few minutes you may have to adjust the flow there in the flow meters. So instead of that, suppose I am administering the gases at a very low pressure to the flow meters, so the flow will be very accurate, it won't change. So that is the main function of the pressure regulator that is used to reduce the pressure of the cylinders. And also again, high pressure gases can produce wear and tear of fine needle valves. And lastly, prevention of barotrauma. Now in the older machines, these pressure regulators, this another question you will be asked about is the master and slave regulators. So oxygen pressure regulator, oxygen acts as a master, and the nitrous oxide regulators are called as the slave regulators for the oxygen. Now you can see this the nitrous oxide pressure regulator. It has got 3 chambers. You can see the 3 chambers: lower chamber, middle, and upper chamber. So to the lower chamber, oxygen is connected here. So these chambers are separated by diaphragms and also springs. So only when oxygen is opened up and because of the oxygen pressure inside the lower chamber, the spring will move up and then open up the nitrous oxide flow. So then only the nitrous oxide can flow. So as long as oxygen is not there, so the nitrous oxide also cannot flow. So this is called as a master and slave regulators. And in modern machines, these have been replaced with fail-safe valves. So I'll just show you a figure wherein you can understand this particular master and slave regulator better. You can see this the slave regulator of the nitrous oxide. You can see oxygen is coming from above. So this is one of the chambers. So this is the second chamber, and the lower down, this is the third chamber. So once on the the right side here, there is no oxygen is flowing into the oxygen chamber because oxygen is not entering there. The diaphragm is flat, and the one of the thrust valve thrust pin that is there, it is moved up and then blocking the inlet for the nitrous oxide. So nitrous oxide cannot enter here. So suppose if you open up oxygen pressure starts entering into the chamber of oxygen. So it's going to push the diaphragm downwards, and that is going to push the valve thrust pin also downwards, and it opens up the way for the nitrous oxide so that the nitrous oxide can start entering into the flow meters. So this is what is called as the master and slave mechanism. But when they introduced this into the older machines, they thought that it's a foolproof thing, but it is not a foolproof thing. I'm trying to show you this particular thing. Many times you are asked to demonstrate this master and slave. Priyanka, are you able to hear my voice?
Yes, sir. You are very audible. Video is not audible. Video is not. We can't hear from the video. Video is not audible.
Video is not audible, is it? Okay.
Yeah.
I'm going to tell you what I'm actually doing. So I'll start the video from the beginning and I'll show you. I'm going to talk about this. Now, what I'm doing here is I'll also just a minute.
So you can adjust in the Zoom settings.
Pardon?
Zoom settings you can go and share audio.
Okay. Zoom settings.
You can go up the view options.
Yeah, that is there, but and there?
There is one share audio, sir.
Share sound.
Yeah, share sound, correct.
Okay.
Now it will work.
Voice basic machine, I just want to demonstrate you how the master and slave mechanism of nitrous oxide pressure regulator as slave regulator to oxygen. I'll just demonstrate. Now what I'm doing is I'm opening the oxygen.
Yes, sir.
So oxygen flow is there, oxygen pressure is there through the nitrous oxide pressure regulator, because I've opened the oxygen cylinder. Now I have kept both oxygen and nitrous oxide. You see I can open nitrous oxide now. So what I will do is, now I will close the nitrous oxide oxygen cylinder. That means there won't be any pressure of oxygen to open up nitrous oxide. So the nitrous oxide also should fall down. So what I will do is, I'm just closing down the cylinder of oxygen. Now there is no oxygen flow. I will remove whatever the oxygen is there in the piping by pressing the flush. Now you can see nitrous oxide is also falling. Now I am trying to open only nitrous oxide, so I will not be able to open the nitrous oxide. So what I am going to do now is, again I will open oxygen. Now I have opened oxygen. So once I have opened oxygen, the problem with the fail-safe systems or the pressure slave regulator system of the older machine, and also the fail-safe valves of the newer workstations. The newer workstations, we have fail-safe valves which have just replaced the master-slave mechanism that was there in the older machine. These are also almost like master-slave only. The oxygen pressure has to be there to open the fail-safe valve of the nitrous oxide. So no, but with this, though they are called as fail-safe valve, they are not actually the fail-safe. I'll just demonstrate with this. So now oxygen is, I've opened the oxygen cylinder. Now oxygen pressure is there, which is passing through the nitrous oxide regulator, and it has opened the nitrous oxide pressure regulator. With this, I can still give only nitrous oxide. See, now I have opened up only nitrous oxide. I can still give the patient only nitrous oxide and without oxygen, and definitely that is going to produce quite a bit of hypoxia. So in order to prevent that, what we have is the proportionating devices that are there at the flow meter level, so that I am going to discuss later. Boyle's basic machine. Boyle's basic.
So now coming to, I think you understood the master and slave mechanism and the fail-safe valves. They are not foolproof. That is the reason why we have proportionating devices at the flow meter level. I'm going to discuss that also later. Now coming to the intermediate system. So in the intermediate system, we have the pipeline connection, and also we have the fail-safe valves, and we have supply alarm, oxygen failure alarms are there. You have pressure, second stage pressure regulator, which is there only in case of GE machines. It is not there in Draeger machines. You also have the oxygen flush valve. So these are the parts of the intermediate system. Let me just discuss about these things. Pipelines, already I have discussed about the diameter index safety system and the NIST connections. So let us discuss about the fail-safe valves. So these fail-safe valve, you can see here, this side is the nitrous oxide. So the oxygen is connected to this fail-safe valve. So because of the pressure of oxygen inside, the nitrous oxide can enter into the flow meters. If there is no pressure inside these fail-safe valves of oxygen, so the nitrous oxide is also cut off. Now there are two types of fail-safe valves depending on the manufacturer, whether it is the GE workstation, it is the shut-off valves. Otherwise, full form of that is oxygen failure sensor shut-off valves, so commonly called as shut-off valves. Whereas in Draeger, they are called as OFPD, or oxygen failure protection device. So this is a shut-off valve. You can see here. So oxygen at 25 pounds per square inch is entering here. So there is a thrust pin is there, and this thrust pin is pushing the valve and opening the valve here for nitrous oxide to flow. What happens if the oxygen pressure drops down below 25? So here, once the oxygen pressure has dropped down below 25 psig, this thrust pin will come down and the valve completely gets closed. So no more flow of nitrous oxide can occur. So any pressure below 25 psig with Datex Nomada or GE machines, it completely shuts off the nitrous oxide flow into the flow meters. That is why it is called as a shut-off valve. Whereas in Draeger, what we have is called as the OFPD or oxygen failure protection device. There is a slight difference between the shut-off valve and this OFPD. Just I am going to tell you what is the difference. Here you can see in the lower chamber, the oxygen at a pressure of 50 psig is entering. Again, it is lifting this thrust pin, and it is connected to a nozzle, and the nozzle is above the tubing or path of nitrous oxide. That means the nitrous oxide is going towards the flow meter at same 50 psig as oxygen. So what happens once the pressure of oxygen starts coming down? So once the pressure is dropping, now it has dropped down to 25. What happens? This nozzle also starts coming down in the path of the nitrous oxide flow. So what it does is it also decreases the outlet pressure of nitrous oxide to 25 psig. That means here 25 of oxygen and 25 of nitrous oxide also. That means it proportionately decreases the output of nitrous oxide. That's why it is called as oxygen failure protection device. And once the pressure comes down to 10 psig, in this also OFPD system also, there is completely the nozzle comes down and totally blocks the nitrous oxide flow. So that is the difference between the GE machines and the Traeger machines. Another is oxygen supply failure alarm. So the standard says that once the pressure drops down to oxygen pressure drops down to 30 psig, so the alarm should start within 5 seconds. So in the older machines, what we had was the whistles were used to be there. Bowman's or Ritchie whistle were used to be there. And here, what used to be there, usually there used to be a separate canister or a small cylinder was incorporated inside the machine itself. And it was connected, it used to be connected to the oxygen source, whether it is from the cylinder or to the pipeline system. And this canister is connected to a whistle. Normally, as long as the oxygen pressure is above 30 psig, so this particular connection between the canister and the whistle is blocked by a valve seat. So you can see here, so the valve seat is, oxygen flow is there, oxygen pressure is there into the canister continuously. So that's the reason this valve seat is preventing the flow of this oxygen from the canister into the whistle. So once the oxygen pressure drops down, the spring will push the valve seat away from the opening here, and whatever the oxygen that is present in the canister will start activating the whistle, and the whistle immediately starts. So this is what was there in either Bowman's whistle or the Ritchie's whistle. The pneumatic alarms used to be there in the older machines. Then they thought that this particular amount of oxygen, maybe a few liters of oxygen, should be used for the patient and not for activating the whistle. And another problem with these kind of whistles used to be that once the oxygen gets exhausted in the canister, they used to stop. But the standard says the whistle or audible alarm should keep on going till we restore the oxygen pressure back. So that is why nowadays what we have is the electronic electronic sensors or their pressure sensors. Even in the older machines, if you can see, sometimes you may be asked about this particular part in the older machine, and this is actually mainly consists of a battery inside and a pressure sensor inside. And once the oxygen pressure drops down to 30 psig, so this will give a audible alarm. So with the modern workstations, we have the alarms which will give an audible alarm. One in GE machines, once the pressure drops down to 28 psig, and in Traeger it about 30 to 37 psig, it drops down. And once you restore, they'll stop. Till you restore the pressure, they keep on with the audible alarms will be there. Coming to one more part of the intermediate system, this is the oxygen flush. This flush, once it is activated, it gives almost 35 to 70 liters of gas. So when do we use this oxygen flush? So one thing you should realize, this oxygen flush is directly connected to either the pipeline source or to the cylinder source. So it bypasses the flow meters and then the vaporizers. So when do we activate it? Is usually when you are holding a mask over a particular difficult airway, difficult mask ventilation patient, wherein there is a lot of leak around. So if you can activate this, So you are actually pushing in the amount of oxygen much higher than what the leak is occurring. So easily you can ventilate. So it's again a safety feature, oxygen flush. You can also use this oxygen flush for checking any leaks in the oxygen machine. So I'll be talking about that also. And also you can use this oxygen flush. So sometimes for the Patrick's test of the main circuit that I'll be talking about when I talk about the circuits. So one problem with this is, when you accidentally activate, unnecessarily activate, it can produce barotrauma. So, and second thing is because it is bypassing the flow meters and then the vaporizers, it can produce dilution of the anesthetic and can produce lighter planes. So in Draeger machines, even if you activate, it may not produce any barotrauma because in Draeger machines, what you have is the fresh gas flow decoupling valve is there. So all the inspired fresh gases, even when you activate the flush, will not directly go to the patient because during the inspiration, all these gases will go to the bag. Only the bag gets expanded. Only during expiration, the gases are taken by the piston from this reservoir bag and it is pushed to the patient. So FGF decoupling valve, sometimes you may be asked, especially what is the safety features that is adopted in Draeger machines, especially accidental activation of the flush. Now coming to the second stage pressure regulator. So these second stage pressure regulators are present only in the GE machines. We don't have the second stage pressure regulators in Draeger. These second stage pressure regulators further reduces the pressure from 2000 ps, the pipeline pressure of 50 to 60 psig and the cylinder pressures of 45 psig are further reduced by the second stage pressure regulators. They reduce the pressure to 14 psig of oxygen and to 26 psig of the nitrous oxide. So this is another very pardon. Anything? So I started late. I'll take another 10 minutes. No problem.
No problem, sir. You take
No
your
problem, sir.
Yes, sir, you may continue.
Oh,
It's a
okay.
PPT.
So
They will.
okay, thank you. So this is the second stage pressure regulator where the pressure of oxygen is reduced to 14 psig and the nitrous oxide is to 26 psig. Again, sometimes you may be asked this particular question: why a difference in the pressure reduction in the pressure second stage pressure regulators in the oxygen and the nitrous oxide second stage pressure regulators? This is mainly, in these GE machines we have the Link 25 system. So in order to create a 3:1 ratio of nitrous oxide to oxygen, this particular difference in this pressures is going to help. I'll talk to you when I talk to you about the Link 25. So this is another very important thing. So what is the advantage of reducing the pressures further? Because reducing the pressures, very low pressured gases are entering into the flow meters till the pressure inside the system drops down to either 14 psig of oxygen or 26 psig of nitrous oxide. The gases continue to flow into the system. So another problem is, many times there can be a fluctuation of the pressures in the system by about 20%. Even though there is a fluctuation, the flow will be very accurate. So there won't be any problem. So this is the advantage of having second stage pressure regulator. But in Draeger, we don't have the second stage pressure regulator. Now this, what in the Draeger, what we have is instead of second stage pressure regulator, we have the flow restrictors. I'll just show you. So these flow restrictors are present just upstream of the flow control valve. So here you can see a narrowing of what they have done is they have totally instead of using costly regulators, they have replaced here with slightly narrowing of the tube here. So you know that based on the Bernoulli's principle, whenever a gas encounters a narrowing, the kinetic energy increases, the potential energy drops. That means the velocity increases, the pressure drops. So automatically the pressure that is going to the flow meters is automatically reduced. So this is easily can be done using just narrowing of the tubings, and these is called as the flow restrictors. that is mainly used in case of Draeger machines. Again, the advantage of flow restrictors is, the costly pressure regulators need not be used. But disadvantage is, suppose if there is a fluctuation of the pressures of these gases, the pressures going to the flow meters also will fluctuate and can produce inaccurate flows. That's why second stage pressure regulators are better than just having a flow restrictors. Now coming to the one of the common questions that is asked for you is, well, how many connections are there for the oxygen source inside the machine? So you have to say in GE machines there are about 6 connections are there. One connection is directly to the flow meters. The second connection is to the fail-safe valve of nitrous oxide. The third connection is to the oxygen supply failure alarms. The fourth is to the auxiliary oxygen flow meter. The fifth is to the oxygen flush, and the sixth is the anesthesia ventilator driving gas. So because in GE machines you have bellows type of ventilators. For bellows type of ventilators you require a driving gas, and the driving gas is always oxygen. So there are 6 connections for the oxygen source in the GE machines, whereas there are 5 connections for the Draeger machines. Because in Draeger machines you have a piston-driven ventilator, you don't require any gas to force the fresh gases to the patient. That is why in Draeger you have 5 connections for the oxygen source. In GE machines you have got 6 connections. Now coming to the low pressure circuit. So the low pressure circuit, it starts from the flow meter assembly up to the common gas outlets. So you have the flow meter assembly, you have vaporizers, you have the check valve, you have the common gas outlet. So let us just discuss about the flow meter assembly. So in the olden days, the flow meter assembly used to have a single flow meter for each of the gas. So the disadvantage with this was you will not be, or you cannot be accurate for low flows. Now, nowadays, we usually majority of the times we go for low flow anesthesia. So if you have got a single flow meter for both high flows and low flows, you may not be very accurate for the low flow anesthesia technique. So that's why in the modern anesthesia workstations, you have 2 flow meters, each arranged in series for each of the gas. Now you can see here, oxygen 2 flow meters, nitrous oxide 2 flow meters, and air 2 flow meters are there. That means the first flow meter, which is for the low flows, you can give up to 1 liter here. So you can be very accurate as far as the low flow technique is concerned. So this again, the question will be asked for you, why there has to be a 2 flow meters and how they are arranged. They are arranged in series. That means this 1 liter will continue into the high flow flow meter. So one more the thing here, you can see just above these flow control knobs, there is a slightly projected part of the flow meter assembly is there. This is called as a guard. So inadvertently you cannot move these flow control knobs. So there is a guard here. So this is another safety feature you should always remember. Sometimes suddenly they may ask you why it is projected like that. So it is a guard for the flow control knobs. Again, coming to the flow control knobs, they are touch coded and color coded. You can see nitrous oxide is blue, oxygen is white, and air is black and white, and touch coded also, because the oxygen is the largest flow control knob, and the fluids are widely placed and they are very large. Even just touching the flow control knob, you know which particular gas flow control knob you are touching. Whereas nitrous oxide and air are small and usually they are conical. This oxygen is cylindrical. Coming to the proportionating devices I was talking to you about. So which produces more safety to prevent any hypoxic mixtures to be delivered to the patient. So in GE machines you have the Link 25, and in Draeger you have what is called as ORMC, or oxygen ratio monitor control. Nowadays it is called as the same mechanism is same. They are called as sensitive oxygen ratio control. Now, how these the Link 25 and the ORMC will function? What is the difference? I'm just going to talk to you about. So this is the Link 25. So you can see there is a chain is there and the sprockets are there. Immediately after the flow control knobs, and before the flow control valves, this large sprocket with 29 teeth for oxygen and a small sprocket for nitrous oxide with 16 teeth are there for the nitrous oxide, and there is a chain is there. Now, why the name Link 25? So what is very important here to know about is the chain will establish the link between the sprockets of oxygen and nitrous oxide only when the oxygen ratio, when compared to the total flows, comes down to 25%. So as long as the oxygen volume of oxygen or flow of oxygen is more than 25% of the total flows, the link will not be established. That is why this particular name Link 25. Now, how this Link 25 will function? You can see 29 teeth sprockets for oxygen and 15 teeth or 16 teeth for nitrous oxide. So, when oxygen is rotated, so nitrous oxide is rotated twice, oxygen will rotate once. So that means the 2:1 ratio is maintained because of this movement of the nitrous oxide and oxygen sprockets. And you can also see at the flow valve level, a slight change. Here, the nitrous oxide has got a wider flow control valve, and whereas the space for oxygen is slightly narrow. So with these two, and also, I told you the pressures. Usually the oxygen second stage pressure regulator will give the oxygen to the flow meter at 14 psig and nitrous oxide at 26 psig. Because of these things, the ratio is always maintained not less than 3:1. 3 times the nitrous oxide and 1 time oxygen is always. That means 25% of oxygen will always be given. You cannot give less than 25% of oxygen because of this Link 25. I'm just going to demonstrate a small video. So I hope you can.
I'll be showing you how to recognize whether the proportionating device, which particularly in that particular workstation you have Link 25 or oxygen ratio monitor control. So it's very simple to detect. Now what you have to do is to just open nitrous oxide flow meter. So you can see when I am opening the nitrous oxide flow meter, the flow control knob of the oxygen is also getting rotated. Now what I will do is I will now close both the knobs of nitrous oxide and oxygen. I'll try to open only oxygen. So I can only open only the oxygen. Now what I will do is, now I am keeping about 3 liters of the oxygen. Now I will make the nitrous oxide to go more than the 25% of the total flow of oxygen. So now you see, when I have increased the flow of nitrous oxide, oxygen is also flowing. But now what I will do is, oxygen has come up to 4 meters. Now I will cut down nitrous oxide. When I cut down nitrous oxide, oxygen will still remain at increased level of whatever it had occurred when I had rotated nitrous oxide. It has not come down because the link has got disengaged. So this is how easily you can make out whether the particular equipment, whether that workstation has a Link 25 proportionating device or a WAR-MC. I'll also tell you in a Draeger machine, because there is a GE machine. GE machines usually will have Link 25, and in Draeger machine, the proportionating device is oxygen ratio monitor control or sensitive ratio monitor control. So that also I'll be showing next.
So this is very important, you see, because many times you will be asked to demonstrate the Link 25. So it's very easy. We just try to open nitrous oxide. When you are trying to move the nitrous oxide flow control knob, if oxygen flow control knob also moves, then you know that that particular equipment, the machine has got Link 25. So we'll come down to the WAR-MC or SORC that is there in the Draeger, which is purely pneumatic, whereas the Link 25 is almost 90% is mechanical and 10% pneumatic. Here, the Draeger sensitive ratio control or oxygen ratio monitor control is purely pneumatic. You can see here the flow meter of oxygen on this side. It is colored, brown, and the other side we have the nitrous oxide. So there are resistors are there for oxygen flow meter also, and there is a resistor inside the nitrous oxide flow meter. The oxygen flow meter resistor is stronger when compared to the nitrous oxide resistor here. And both these flow meters are connected to two different chambers. Now you can see oxygen is connected to an oxygen chamber, nitrous oxide is connected to a nitrous oxide chamber. Both these do have the diaphragms, and these diaphragms are connected by a shaft. Now what happens is, and there is a slave control valve is also there on the nitrous oxide side. So when I open up oxygen, the flow of oxygen will move this particular shaft towards the nitrous oxide side, and it will open up the slave control valve of nitrous oxide so that the nitrous oxide can flow in. Suppose I have not opened up oxygen, so then you cannot open nitrous oxide also because the slave control valve is closed. Suppose I have opened up oxygen and I am trying to increase the amount of nitrous oxide. So if I try to increase the nitrous oxide flow, what will happen is the nitrous oxide also comes back into the nitrous oxide chamber, and it is going to push the shaft towards oxygen, and it is trying to cut down its own amount of nitrous oxide flow by decreasing the space for nitrous oxide slave control valve. So this is what is called as ORMC. I'm just giving you another video because sometimes you may be asked to demonstrate this also, how this particular SRMC is going to work. So we'll just
So I'll be talking about, you can see here SORC is there, a sensitive oxygen ratio control in Draeger KBS machine, KBS Plus cases. We'll just see how it differs from Link 25, because Link 25 is purely mechanical, whereas this is the totally pneumatic one. So you just see, now I'm trying to open nitrous oxide, because in Link 25, if I open nitrous oxide, automatically the oxygen flow control knob also would rotate and oxygen also would come out. Now with here with ORMC or SORC, now I am trying to open nitrous. See, I am rotating the flow control knob of nitrous, oxygen is not moving. So because oxygen has to flow into the nitrous oxide side and then push the piston, then only nitrous oxide gets unlocked and then nitrous oxide can flow. So that is one of the things which is very important. Now I can, if I am opening oxygen, I can only open oxygen. So nitrous oxide initially it has come up, but it has fallen. So I can give only oxygen here. Now let us see that I am giving 1 liter of oxygen here. So you can see 1.5 liters of oxygen. Sorry, this is 1 liter of oxygen, right? So I will try to open nitrous now. So now we will see how when the oxygen also will start increasing, or whether it will increase or not. So you can see here I have gone up to 3 liters. So you see it has come up to 3 liters, and this is 1 liter. So out of 4 liters, 3 liter, 1 liter is oxygen, that is 25% is oxygen. Now I am trying to increase nitrous, but I am not able to increase nitrous. See, I have opened nitrous more, but still nitrous oxide is not coming up. So see, I will try to open now oxygen. So nitrous oxide also will increase proportionately, because now I am keeping about 3 liters of oxygen. See, now you can see almost the nitrous oxide is almost about 8 liters. So still that same proportion is maintained. Suppose I am trying to reduce now. So if I am reducing, again nitrous oxide is also reducing. So if I reduce it to 0 oxygen, nitrous oxide completely falls. Again, if I want to open oxygen, again nitrous oxide is also coming up. So this is the SORC or ORMC of Draeger system when compared to the Link 25 of the GE system. So I'll be talking about.
So coming to the flow meters, these flow meters are made of hard glass, which is called as plexiglass, and the flow meters are called as top tubes. And inside again, these top tubes, you should know that it is made of plexiglass. That is also one of the questions that is asked. And inside it is sprayed with a special material called as croxtine. and this Croxtin will prevent static electricity, because the movement of the bobbin is electricity is produced. If the electricity is not moved away and if it stays there, the bobbin gets stuck to the inner wall of the flow meter. So that is the reason that you have an anti-static material sprayed inside, so that the bobbin, sticking of the bobbin is prevented, and the material is called as the Croxtin. So one more thing here, you should always see here, the tube is tapered. So sometimes they may ask you why the tube has to be tapered. The tube has to be tapered to reduce the length of the flow meter. Suppose if the tube is not tapered, because in the lower flows, the the length of for the same measuring unit is much longer. As you go up, the annular space will increase, the length of for the same amount of flow will decrease, so that overall the length of the flow meter will decrease. So in order to decrease the length of the flow meter, you have the tapering of the tube. So if you have a single tube for the gas, so then you will have a double tapering. And if you have two flow meters for each gas, like for low flow one tube and the high flows another tube, then each tube will have a single taper. So that is another thing which also you should know. And these another very important thing is that there is a stop at the top. This is again a safety feature. It prevents the bobbin to get lost into the hind bar. So now coming to the flow meter and the bobbin. So what is the principle behind this floating of the bobbin? Because there is a force from above, because of the weight of the bobbin. These bobbins are made of aluminum. It's very, very light, but because the gravity force is there, which is trying to push the bobbin down. So but the gas pressure is also there, pushing the bobbin up. As at any particular flow, an equilibrium is created, and the bobbin will stay there, and it keeps rotating. So why it rotates? Again, there is the corrugations are there, or flutes are there, which is oblique flutes are there. Once the gas hits this oblique flutes, so it will make the bobbin to spin. So that's how the bobbins will keep rotating. So one more white dot will be there over the bobbin. This is a fluorescent dot. Suppose if I'm using the the machine in darker areas, especially in the radiological suits, so you can just see this fluorescent dot, and you know that whether the flow is occurring or not, the bobbin is rotating or not. So these are all some of the minor things which can be asked for you in the exam. So you should always know about this, the fluorescent dot that is there. So on either side of the bobbin, the space that is called as the annular space. You can see here the lower flows have a smaller annular space. In higher flows, you have a larger annular space. So in modern workstations, you may not have the flow meters. You have electronic flow meters, and they'll be showing how much is the flows. So that's what here I'm just showing the monitor photograph of the Taken machine. You can see here the total flows it is showing as 1 liter, and oxygen percentage as 70%. You can see just more than 0.6 or 0.7 liters of oxygen and 0.3 liters of nitrous oxide. So these are in the modern workstations. You can also have the electronic flow sensors and flow meters. So now I was talking to you about the annular space. So this is the annular space in between the bobbin and then the inner wall of the flow meter. So why you should know about this is for the lower flows, because the diameter of the flow meter is very small in the lower part because they are tapered. So what happens is the space of between the bobbin and the inner wall of the flow meter is also small. So that's how it looks like a tube, because the length is much longer than the width. So the flow is also the tubular or laminar. So whenever the flow is laminar, it always it obeys Hagen-Poiseuille's law, where flow is inversely proportional to viscosity. As you go up, as you start giving higher flows, because the annular space increases, you can see the width is much higher than the length. So this kind of a opening is called as an orifice. So the flow will be orificial, or otherwise also called as turbulent. So the flow becomes turbulent in the higher flows of the flow meters. So why we should know, again, exam question is lower flows. I told you Hagen-Poiseuille's law, because the flow obeys the viscosity, because they obeys the Hagen-Poiseuille's law, where its flow is inversely proportional to the viscosity. And with the higher flows, because it is the turbulent flow, it obeys the Graham's law, wherein the flow is inversely proportional to the square root of density. Now, why it is important to know is all these flow meters are calibrated at atmospheric pressure of 760 millimeters. So that is at the sea level. So suppose these calibrated flow meter, the workstation, I am using it in Ladakh or high altitude area. So where the viscosity of the gas will not change, but the density of the gas will come down. Because the density of the gas will come down, suppose I may be giving, say, higher flows of maybe 7 liters, actual flows going to the patient maybe 9 liters or 10 liters. And the problem here is the nitrous oxide may go more to the patient when compared to oxygen, and actually you may be giving a hypoxic mixture to the patient. That is why if you want to use it in a higher or any particular change in the altitude, you have to have these flow meters calibrated to that particular altitude. Another very important thing for you to know, these flow meters are calibrated for that particular gas with a particular viscosity and density. So you can't interchange these flow meters. Suppose if the oxygen flow meter is broken, you can't replace it with nitrous oxide flow meter. One more common question that is asked is the arrangement of these flow meters, how they are arranged. Now you know that with all modern workstations, oxygen is always placed downstream for all the gases. Why it should be placed downstream of all the gases is a question that is asked for the students. See, suppose if oxygen is upstream and air is in between, suppose if this air flow meter is broken, so what will happen is oxygen will be flowing out, whereas the patient will be getting more of nitrous oxide. So that means the patient can get a hypoxic mixture. So if you have the oxygen as the most downstream, so even if there is a break in the air flow meter, then nitrous oxide will be going out, but not the oxygen. So that is why in all the modern workstations, the most downstream flow meter is always the oxygen. Now, in the older machines, you also have a check valve and a pop-off valve. Sometimes you will be asked about this pop-off valve and check valve. So you'll be asked, what is this? So you have to identify this as the check valve and the pop-off valve. So what happens is, if there is an obstruction to the common gas outlet, so or whenever I am ventilating the patient with positive pressure ventilation, so there is the positive pressure going to the patient and also a back pressure going towards the vaporizers and the flow meters. So in order to prevent that back pressure and also to prevent pumping effect and then the pressurizing effect that can occur with the vaporizers, we have what is they called as a check valve. Suppose there is a complete obstruction, high pressure starts getting into the system, so that can even damage the flow control valves. So in order to prevent that, the pop-off valve will open up and it will release whatever the high pressure that is there. So this is what is pop-off valve and the check valve. So this is just a small video.
Now you see, this is the pop-off valve and also a check valve. Both are there in Boyle's basic machine. I'll just show you. So when I block here, how the whenever the back pressure goes, now I've opened up oxygen. So I'll close the common gas outlet at a pressure of about 300 centimeters once it develops. So the pop-off valve will open and you can see the gases going out. You can hear a hissing noise. So what I have done is I have blocked this. If you can come be close by, can you record that hissing noise? See, I have just closed. You can hear the hissing noise here. Now it is better heard because once the pressure has developed. So this will not, because of this pop-off valve, so the pressure, back pressure effect onto the vaporizers and to the flow meters is decreased. So this is what is pop-off valve, and this is a check valve.
So now one thing I want to tell you that, there are no safety features between the flow control valves and the common gas outlet. So that is why before using the workstation, you have to check for the leaks. So there are two types of leak tests are there: positive pressure leak test and the negative pressure leak test. The positive pressure leak test, that you have to open oxygen, or you can even activate the flush and then increase the pressure to 20 centimeters of water, and then just see if this maintains the pressure for about at least about 10 seconds. That shows that there is no leak, that you will be doing almost every day. So this you have to do with opening the vaporizers as well. Suppose if there is most of the time there can be a leak at the vaporizer level. So if there is a leak, you can see here the the pressure has dropped. So that's how this positive pressure leak test is done. But if you have a check valve, you will not be able to do this positive pressure leak test. So this is also an exam question. If you have a check valve, so which is the leak test you are going to do it. So here I'm showing you, if you are doing a positive pressure leak test, if you have got a check valve, it will only check from the check valve to the common gas outlet. And if there is a leak in the vaporizer, it will not be able to detect it. So that's why you have to go for what is called as a negative pressure leak test. So in the negative pressure leak test is also called as a universal leak test. Even if there is a check valve is there, then also you can use the negative pressure leak test, wherein you have a sphygmomanometer. You can use that also. So you have to keep compressing the bulb, and once all the gases are removed, it collapses, and it should remain collapsed. The bulb should remain collapsed for at least 10 seconds. Now you can see here there is a leak here, which the collapsed bulb is just inflated again back. So that means there is a leak. So this is called as a negative pressure leak test, which is done for both Draeger machines where there is no check valve, and also GE machines where there is a check valve. That is why this negative pressure leak test is called as a universal leak test. Whatever it may be, you should always have an oxygen sensor at the patient end, so that the hypoxic mixture should not be delivered to the patient. So this is the most important thing, because hardly any safety measures between the flow meters and the common gas outlet. So you have automated leak tests nowadays. It is there, and majority of the times we'll be doing this automated self checkout, and all the tests have to be passed before you use it. So just to conclude, see, a lot of changes have been made over the years. A lot of things have been added, but whatever it may be, an oxygen analyzer and a vigilant anesthesiologist is the most important thing, because new solutions can produce old problems. For new solutions for old problems might raise new problems. So it is always the vigilant anesthesiologist and an oxygen analyzer a very, very important thing for managing any kind of anesthesia. So thank you very much for patient listening. I almost took 1 hour 45 minutes. Thank you so much for giving me extra time also.
Sir, we have one question.
Yeah.
Yes, please continue.
Sir, one person has asked, who does the testing of the cylinders?
Testing means which testing? You are
in general they have
test, or what testing actually?
No. I meant about they meant about the other tests, the hydraulic test and all that.
That usually the company people will test. And here in Mysore, I used to take my students. When I was in the Mysore Medical College, I used to take my students, and there, the test used to be demonstrated to the students by the company people. It is always done by them only, the manufacturers.
Okay, sir. Okay. So that is the only. Thank you, sir, for your excellent discussion on the anesthesia machine. we now move
So
on to the
here,
next session.
Questions.
It
Now my one more session is there regarding the breathing circuits after the other 2 sessions.
Yes,
There are
sir.
any questions I can answer
Yes.
then also. No problem.
There is one more question.
That
sir.
time
There is-
also, yes, sir. We expect more questions to come up by then. Sir, is there any diameter for the Bodak seal?
No. You need not have to know the diameter
There
of
is
the
no
Bodak seal.
diameter.
Yeah, no.
And there is no question about the diameter and weight of round bobbin as well. There is a question like that.
Very light. They are made of aluminum. Very
Any
light. Yeah, there is
Aluminum.
nothing specific.
Okay,
Yeah.
sir. Okay.
So there is one more question,
Okay,
please.
sir. Thank you very much.
Connections of power devices in Boyle's machine.
Pardon?
Is connections of power devices in Boyle's machine.
I did not follow the question actually.
I think that's
I
a
don't
question
know.
in YouTube.
Not able to follow what the
it's,
question means. Power devices.
We'll ask. So we'll ask the person directly to.
Yeah, I can answer during the breathing circuit session.
Yeah. Thank you, sir.
Thank you, sir. Yeah.